So for question number 1, okay, our givens are as follows. We know the mass of the oscillator. Okay, it's 2.4 kilograms. Okay, and we know the spring constant of the, so we're looking for the spring constant of the spring, and the period is 1.4 seconds. Okay, so I'm looking for spring constant. I've got mass and I've got period, which means I'm going to be using this formula, 2 pi times the square root of m over k. It's not going to, I'm going to have to manipulate for k, so I'm going to square everything. So that'll be t squared equals 4 pi squared times m over k, okay? And then I'm just going to switch k and t squared. So we'll have 4 pi squared times n over t squared, okay? And that'll be 4 pi squared times 2.4 divided by 1.4 squared. Okay, so give them 1 mark for their givens, give them 1 mark for this manipulation. Okay, you know what? This should be out of 4. We're going to say it's out of 4. Okay, give them 1 mark for deciding that that was the formula they needed. And then our final answer. Okay, so we're going to have 4 pi squared times 2.4 divided by 1.4 squared. All right, so we're looking at a spring constant here of two significant figures. 48 newtons per meter. Fourth and final mark there. Questions on number 1. Okay, question number 2 is like what we were working on yesterday. Okay, on question number 2, I know the mass is 1.5 kilograms. I know the spring constant is 29.0 newtons per meter. Okay, I know that one of the displacements anyway, okay, is 25 centimeters. So I'm going to say x1 is 0.25 meters. Okay, and it's moving at 3.4 meters per second. I'm looking for the maximum speed of the mass. Where does the maximum speed occur? At equilibrium. What's the displacement at equilibrium? 0. Okay, give 1 mark for that. Second mark, recognizing this is a law of conservation of energy question. Okay, and what we're dealing with is this. We have an initial potential and an initial kinetic and only a final kinetic, because the final spot is at equilibrium. All right, so that's going to mean 1/2 kx squared plus 1/2, ax1 squared, 1/2 mv1 squared, okay, equals 1/2 mv max squared. Okay, what can I take out of every single term right now? The halves, yeah. Okay, so I want to get v max by itself, so I'm going to divide both sides by m, and then I'm going to square root that. Okay, so give them a mark if they had something along the original formula there. Okay, that's up to 3 marks. Give them a mark for their manipulation. So that'll be 29. Sorry, that looks like 2.9. 29 times 0.25 squared plus 0.5 times 3.4 squared, okay, divided by 1.5. So, fourth mark, sorry, I'm not solving for V max. Okay, so our maximum speed, okay, we're going to have 29 times 0.25 squared plus 1.5 times 3.4 squared, okay, divided by 1.5, square rooted. Okay, so at equilibrium, this thing's not actually moving a whole lot faster than it was at that other position. Okay, but it is moving to 2 significant figures, 3.6 meters per second. Fifth and final mark there. So it's out of 9, not out of 8. Okay, so we can give a mark out of 9 at the top. let them see it, double check your name is on it, okay, and then you can bring them up to me.